Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, go ahead and hit the subscribe button because you're in the right spot. That said, let's get into the current video. I'm going to discuss the concept of function composition, and in particular, how do I evaluate a composition? Let me go ahead and remind you of the definition of function composition. So definition: the composition of f of x and g of x evaluated at x equal to a is given by the following. Okay, so first let me show you the notation for it. The composition operation uses the little circle in between the two function names, so f composed with g, and I group that together, so I'm evaluating that function at the value a. Now how do I do this? Well, let me describe it before I write it. The input first gets plugged into the function g. I compute that value. Then that function value, g of a, is now the new input for the function f. Therefore, I write this as f evaluated at the value g of a. I use two different size parentheses just to emphasize the fact that the number a first gets plugged into the function g. I compute that number. That then is my input for the function f. So notice g of a is my input for the function f. Let me illustrate this with examples. Let's say f of x is x squared plus 4x, and g of x is given by 3x minus 1. And let's say part A, I want to evaluate f composed with g of 1. Part B, let's do g composed with f of, let's say, negative 1. Okay, so how do we do that? Okay, solution. F composed with g of 1. So again, let me write the notation that was stated initially, f composed with g of 1. Now I'm going to go to my definition here, and this says that I take the number 1 and I start by plugging it into g. I compute that function value, g of 1. That is my input then for f. Again, notationally, this says I'm going to take the function f, and the input for f is g of 1. So what I have to do is compute g of 1 first. To compute g of 1, I'm going to use the input 1 for this function down here. And notice when I plug 1 in, I'm going to get g of 1 equals 3 times 1 minus 1. So let's go ahead and write that out. I get 3 multiplied by 1 minus 1. And this is going to be 3 times 1 is 3. 3 minus 1 is 2. So therefore, f of 2. So again, 2 off to the side here. 2 is the function value g of 1. All right. Now I'm going to use the input 2 for the function f. And the function f takes an input and squares it, and then it multiplies the input by 4 and then adds those two results together. That said, I'm going to get 2 squared plus 4 times 2, which would be 4 plus 8, which is equal to 12. So if I plug one value in, of course I get one value out because it's a function, and we do it by using composition, one function at a time. Notice I started on the rightmost function and I work my way to the left. All right, let's go ahead and work through part B. Okay, I'll leave these up here just as a reminder of what the functions were. Part B, g of f of negative 1. So g of f evaluated at the value -1. Okay. Notice that I reversed the roles of g and f in this case. In other words, in part A, we use the function g first, and then I use the function f, so I go from right to left. Here I am using the function f first because it's on the right, and then I'm going to move to the function on the left. So for composition, order does matter. Okay, and I haven't illustrated it yet, but composition is a non-commutative operation that just simply is a fancy way of saying order matters. Okay, so g evaluated at f of -1. -1 gets plugged into the function f first, so I'm going to use this expression. That means my input for g after I simplify is going to be -1 squared plus 4 times -1. Okay, so let's compute that first. -1 squared is 1. 4 and -1 is -4, so 1 minus 4 would be -3. Now I'm going to use the input -3, which remember was f of -1. I'm going to use that as my new input for the function g. Remember, the function g multiplies the input by 3 and then subtracts 1. That means I'm going to have 3 times -3 minus 1. Of course, 3 times -3 is -9. Minus 1 would give me -10 for my result. Okay. All right, let's practice with another couple of examples. Okay, this time let's say f of x is, let's do -x squared plus 1, and then g of x is going to be, let's say, x squared minus 4. So I'm going to put a variety of computations up here, and then why don't you go ahead and pause the video and work ahead to see if you can get the right answers, and then play it to see if we match. Part A, I want you to try f composed with g of 2. Part B, let's do g composed with f of, let's do -2. And then part C, do f composed with f of, let's say, -3. Okay. So go ahead, pause the video, and resume it after you try them. Okay. So maybe you paused it, maybe you didn't. I don't know. But let's go ahead and work through all three of these. So solution. Grab a different marker. It looks like that one's running out of ink. Solution, part A. Okay. F composed with g of 2. F composed with g of 2. This means f evaluated at g of 2. All right. What do I do first? Well, notice that the number 2, the input 2, gets plugged into the function g. Function g is x squared minus 4, so that means that when I plug this in, I would get 2 squared minus 4. And of course, 2 squared is 4, so 4 minus 4 is 0. That gives me f of 0. Now I'm going to use the input 0, which was the output for g. I'm going to use that input for my function f. F takes takes the input, squares it, multiplies by -1, and then adds 0. That means I would have -0 squared plus 1, which of course is positive 1. Okay, clean this up, and then let's do B and C. For B. G of f evaluated at -2. All right. Notation-wise, this is g evaluated at f of -2. And what do I get? If I take negative 2 and I plug it into the function expression for x, this would give me, so here's, again, order of operations, right? I'm going to square the input. So negative 2, I'm going to square it. So I'm going to group together negative 2 in parentheses and square it. Then I'll multiply that by negative 1, and then I will add 1. Okay, so what does that give me? Negative 2 squared is 4. So this would be negative 4 plus 1. Of course, negative 4 plus 1 would be negative 3. Now I'm going to use negative 3 and plug that into the function expression for g. This would be negative 3 squared minus 4. And of course, negative 3 squared is 9. 9 minus 4 would give me a 5. Okay. All right, and then the last one, we've got part C. Do that one down here. F composed with f of negative 3. Now, a lot of times students find it very strange to do f composed with f, so a function composed with itself, but it simply means that I'm going to take this number, plug it into this function, and then I'm going to take whatever that is and plug it back into the same function. It's same process we've done in the last handful of examples. So negative 3, and I plug that into f. That would give me, so I'm going to take negative 3 and I square it, multiply by negative 1, and then I'm going to add 1, right? So for this expression right here, square the input, multiply by negative 1, and then add 1. So that's exactly what I have in this expression. And then I'm going to go ahead and simplify. So negative 3 squared is negative 9. And then negative 9, or I'm sorry, positive 9. Well, it will be negative because I've got this negative here. So 9, negative 9 plus 1, which of course would be negative 8. Now I'm going to take the value negative 8 and plug it into the function f. Well, what does that give me? That would give me negative 8 squared and then plus 1. Okay, and come over here and clean this up. Okay, so I'm going to clean this up. Negative 8 squared would be 64 with a negative in front, so negative 64 plus 1, which would give me negative 63. Okay. Thank you for watching, and please consider subscribing.